This is a video for AQA Further Pure Mathematics, Complex Numbers, section 3.7. We're looking at regions defined in the complex plane. Well, as our first example, we're going to look at this. The modulus of z minus 3 minus 4i is less than or equal to square root of 5. Now, as in previous videos, the first thing we need to do is to just rearrange that left-hand side so that we can decide that the point that we're considering, the fixed point here, is at 3 plus 4i. We put that onto an Argand diagram, then we consider what do we mean by less than or equal to root 5. Well, we've met already the locus of points where we have equal to, so equal to root 5 would be a circle of radius the square root of 5. Now, the square root of 5 we can find on our diagram by looking at Pythagoras' theorem, and we can see here that we've drawn a triangle which has a length of 1 and 2, and therefore the hypotenuse has got a length of the square root of 2 squared plus 1 squared, which is the square root of 5. So our circle, if we were looking at equal to, would be the circle with z1 at 3, 4 as the centre and radius of root 5. Now, because we've got less than or equal to root 5, it's not just the circle itself, but everything which is inside the circle that we're considering. So there we have that region of the plane is less than or equal to the square root of 5. Now we can change that inequality around a little bit. This time we have the same circle, but the region doesn't include the circle itself, the circumference of the circle. So we indicate that with a dotted line. We can carry on changing the inequalities a little bit. So here we've got greater than or equal to root 5. So this time it's going to be everything which is outside the circle and includes the circle itself, so we have there a solid line for the circle. We're now moving on to regions which are defined using the argument. So here we've got 0 is less than the argument of z minus 2 is less than or equal to pi by 4. You remember from previous lectures that the argument of z minus z1 is equal to some angle theta is a half line from z1 in the direction of theta. So this one is going to have here two lines, one with a direction of 0 and the other one with a direction of pi by 4. So there it is. Now the region that we want is less than or equal to the pi by 4, so it's going to be below the line and including the line, the diagonal line, but it's strictly greater than 0, so you can see that the line at the direction 0 is dotted. Now the region that we require then is above the real axis, so it's those values of y which are greater than 0, but it's below the line which is radiating out at pi by 4. That line there, and that, if we look at the equation of that, that's going to be y is equal to x minus 2. So we want the region which is greater than y is equal to 0, so y is greater than 0, and below y is equal to x minus 2, so y is less than or equal to x minus 2. And if we just shade that region to show and emphasize which region that we're talking about. Well, that's the end of this video, and indeed the last of the videos in section 3 on complex numbers.